And there we go. All right, so where am I? I'm apparently losing my brain today. That's apparently what's happening. We've got to finish chapter 4 and hopefully start chapter 5, but who knows? So, yeah, I plugged it back into the original to find the y value. That's exactly what I did. I assume you're still talking about where did I get the -4 from. So remember last time we talked about global maxes. We started from scratch the other day. Like we hadn't talked about global maxes and mins at all, right? And then we talked about it on Tuesday. Okay, so we went over global maxes and mins, and we also talked about it in terms of kind of these contextual problems. There are no contextual problems on your quiz. They're just going to be like the ones we just did. Here's a function. Here's an interval. Do the thing. The only thing that's different in 4.4 is pretty much nothing. It's doing it on profit, revenue, and cost. Yeah, Brianna, quiz is going to be like the warm-up. So essentially, we're going to take the things we just learned last time and just use them on profit, revenue, and cost functions. So, of course, if you're running a company, there's a very important question of when is profit maximized? When the heck do I make the most money? So we can use the techniques we've already been talking about, but there's also one kind of extra way we can figure it out as well. So if you think about it, if I'm talking about trying to maximize profit, what would you have to do to start doing that? You would find the derivative and set it equal to 0, right? So you would have to find the marginal profit and set it equal to 0. So if you think about making it right things, if you think about the fact that we would want to look at when the derivative of profit is 0. Remember that profit is made up of revenue minus cost, and so is the derivative of profit. The derivative of profit is made up of the derivative of revenue minus the derivative of cost. So finding when the derivative of profit is equal to 0 would be the same thing as finding the marginal revenue minus marginal cost. I'm not going to switch to marginal because saying derivative of and then the right function was making my brain hurt. So essentially, one other thing we could do, say we don't have the profit function and we're too lazy on that day to find it. What we could do instead is, if you think about doing some algebra on this, if you add the marginal revenue over to the other side, whoops, I said marginal revenue. If you add the marginal cost over to the other side, you get marginal revenue equals marginal cost. So you don't need the profit function if you don't want to. You'll still be maximizing profit. But say you only have the cost and revenue functions and you don't feel like finding the profit one, maybe it's super hard or whatever, or you're just feeling lazy. You can also find those same points by just setting the marginal revenue equal to the marginal cost. Which is pretty much what we're going to do in this next example. We're going to say, let's be too lazy to find the revenue profit function, even though it wouldn't be too hard with these ones. And let's just use this new idea of marginal revenue equals marginal cost. So find the quantity which maximizes profit if the total revenue and total cost in dollars are given by those two functions, where Q is the quantity and we're given the interval 0 to 1,000 units. What production level gives the maximum profit? So again, in general, you would want to say, I want to maximize profit, so I want to find profit, find its derivative, set it equal to 0. But we've just said we don't necessarily have to do that if we can just find marginal revenue equals marginal cost. So let's go ahead and find the derivatives of both of the revenue and cost, and then we're going to set those two equal to each other, and that will give us the numbers that we need. Those are going to give us essentially the critical points. Let me write that up here. Find critical points of the profit function, even without having the profit function. So we've got the revenue of cost would, sorry, what did I just say? The derivative of revenue, I don't know where my brain is going. Derivative of revenue would be 5 minus 0.006 Q. It's been a long week. I thought yesterday was Tuesday, and it was a weird time. And then the derivative of cost is just going to be 1.1. So to find the critical points we need, we can just set these two equations equal to each other. I know it looks kind of gross, but it's going to come out to a semi-nice number. So I'm going to subtract 5 from both sides. If you subtract 5 from both sides, what's the number? Negative 3.9. There it is. Woo! Divide both sides by negative 0.006 Q. You're going to get that Q equals 650. So essentially, if you're thinking about this in a general global extrema type of way, we have our critical points, and now how we finish it depends on what type of interval we're working over. We're given an interval that includes both endpoints. So since those are less than and equal to, it's going to be a closed interval. So if I want to write it, sorry, go away. If we want to write it kind of how it was written before, this would be between 0 and 1000, closed brackets. So since we're on a closed interval, we don't need a number line. We just plug all of those into the original function and compare y values. Now, the only thing about not finding the profit function here is that we need to make sure that we're remembering that we need to find these things for profit, but we can just plug it into revenue minus cost. So we still don't need the official profit function at all. So we need to look at Q equals 0, Q equals 650, and Q equals 1000. And we want to look at the profit values of those. Well, maybe I should have put the numbers in there. So we'll have revenue at 0 minus cost at 0. So if I plug in 0 to the original revenue function, we essentially get 0 minus 0. So 0. And then if I plug 0 into the cost function, I'll get 300 plus 0, so 300. So our profit at 0 is negative 300. I'm going to hope that that's not my max profit, because that'll make me sad. If I plug in 650, so we need revenue at 650 minus cost at 650. I'm just going to kind of give us the numbers and trust and believe we could punch that into a calculator. This will give us 1982.5 minus 1015. So 967. I'm going to write 50 for the final piece because we're talking about Monets. If we plug in 1000, so revenue at 1000 minus cost at 1000, it's going to be 2000 minus 1400, which is 600. At this point with these types of questions, you then pick the largest number or the smallest number, depending on which one you care about. We care about maximizing profit, so we care about the largest profit that we got out of here, which says the 967.5. And so we just want to write out a final answer. Now, again, this is technically a contextual problem. So again, I think I said this the other day. You always kind of want to go back and triple check what they actually asked you for, so you actually answer it correctly. So they asked what production level gives the maximum profit. So, okay, I'll go over that in just 1 second. Let me just write this. So maximum profit occurs when Q equals 650. You could tell them what the maximum profit is as an extra little tidbit, but technically they just asked for the production level, so you really just need to state the Q value. The reason we set the marginal revenue equal to the marginal cost is because of this kind of tidbit that we discovered up here before the problem. So if you think about what we want to do in a generic global extrema question is we want to take the thing we want to maximize or minimize and we want to take its derivative and set it equal to 0. So if we want to maximize profit, we would want to take the derivative of profit and set it equal to 0. But if you remember that the profit function is made up of revenue minus cost, then finding when the derivative of profit is 0 is the same as finding when the marginal revenue minus the marginal cost is 0. And if you add the marginal cost over to the other side, we end up with the fact that marginal revenue would be equal to marginal cost there. So we kind of have a choice for maximizing profit. We can either set the marginal profit equal to 0 directly, or we can set the marginal revenue equal to the marginal cost, and it gets us the same values. So I set the marginal revenue equal to the marginal cost here because that's going to be equivalent to setting the marginal profit equal to 0. Does that make sense? Back-to-back classes makes for a very loopy me. All right, Q. So, any more questions on that one before we do one last one? And I dropped my pen. Alrighty. We probably won't get to chapter 5 today. That's a little sad, but it is what it is. So this one is a little bit of a flashback in a way. Like the first two pieces are kind of flashback questions, and then the third piece is the actual thing we're talking about now. So at a price of $80 for a half-day trip, a whitewater rafting company attracts 300 customers. Every $5 decrease in price attracts an additional 30 customers. First thing we want is the demand equation. Then we want to find the revenue as a function of price and then actually maximize that revenue. First thing, I'm eventually going to want revenue as a function of price. Go away. Sorry, I tried to make this notification go away and I closed my Teams. There we go. No, wait, that's wrong. I shared the wrong thing. Oh, Lord Almighty, help me. All right, there we go. We want revenue as a function of price eventually. So why don't we go ahead and find the demand as a function of price as well, so that we don't have to do any extra algebra at the end of it and change it in terms of P. So if I want to find, I should have also said assume it's linear. That's on me. We're going to assume the demand is linear. So I guess I probably should have put that down here. Anyway, I'm losing my mind, guys. Having a bad time. So if we're assuming it's linear, what we have is we're going to have some Q equals MP plus B. Well, if we look at the information we're told that $80 is going to attract 300 people. So the price would be 80, the quantity would be 300. So we have a point. And then the other piece of information is actually going to tell us our slope. So we're not actually given a second point here. We're actually told how to find the slope. So if you think about what the slope is going to be here, it's going to be some change in Q over change in P. Change in quote unquote Y over change in quote unquote X. So I'm told that we decreased the price by $5. So that means our change in P would be -5. And we gain an additional 300 people. So the change in Q would be, 30 people. You get 30 people. So the change in Q would be 30, which means that our slope's going to be -6. So change in price was -5. Change in people was 30. 30 divided by -5 is -6. So now that we have a point and a slope, we can find the equation of the line. This is where we plug those things in and solve for B. 300 equals -6 times 80 plus B. Trusty notes, help me. So we have 300 equals -480 plus B. So B is 780. And I'll slow down a sec. Well, let me write the actual demand equation now. So our demand equation would be negative 6p plus 780. So that's the answer to the first part of our question. I see people scribbling, so hold on a couple seconds. What we're going to want to do now is we're going to want to use that to find revenue, which we've done before, but maybe you don't quite remember. Can anyone remind me way back when we first saw revenue, what we said it was equal to? Quantity times price, yes. So since revenue equals price times quantity, and I just found what quantity is equal to, I can say that revenue is price times negative 6p plus 780. Distribute the p through, negative 6p squared plus 780p. I'm doing that just because the next thing we're going to want to do is we're going to want to maximize it. So I'm going to need a derivative. And if I don't distribute it, then I have a product rule, and that's me. If I distribute it, I don't have a power rule anymore, product rule anymore. What up? The definition of revenue. But think about it, Anastasia. If revenue is the amount of money you make, it's going to be how many items you sell times the price you're selling them for. Okay. So the sassy answer is it's just a definition. But if you think about it a little bit, it does kind of make sense why that is the definition of revenue. So we're here. So this is the answer to the second part of the question. That's our revenue function. And now we're asked to maximize it. What price should the company charge to maximize revenue? So, so first thing we always need is the derivative. We need the critical points, so we need the derivative set it equal to 0. Also, I haven't been saying it for any of the ones that we did today, but none of the things we've been working with have had denominators, so they were never undefined. Technically, I should have kept saying that, but I've forgotten. So revenue, the derivative of revenue will be negative 12p plus 780. Set that sucker equal to 0. It's never undefined because there's no denominator, so we don't have to worry about that. Solve for p. You'll get 65. At this point, once you have your critical points, the rest of the problem then depends on what type of interval you're looking over. We're not explicitly given the interval here, so we have to take a couple seconds to figure out what it is. So we're working in terms of price. What's the smallest price could be? Well, technically, they could let it be free. Like, that would be a little silly, but they could technically do it, right? So it could be a closed interval at 0. Because they could let it be free. Again, that wouldn't make a lot of sense for a company, but they could do it. Negative numbers don't really make sense because then you'd be paying them to come to whitewater rafting. And I guess technically you could do that, but no. It cuts off at 0. But then what's the largest price you could charge here? You could make it however large you want it to be. You'd be a jerk after a little while, but you could make the whitewater rafting $1 million each. Then all the rich people think it's fancy whitewater rafting and they come do it anyway. That actually sounds like a great business plan. Just kidding. Don't take my business plan advice. Anyway, so now we have our interval, and since that interval includes an infinity, we need to unfortunately use our number line case. I say unfortunately because I think it's the one I like the least. So I'm going to go ahead and remind myself that I'm going to cut that off at 0. And I'm going to put my critical point on there. So remember, the reason we need to do the number line is because when you're dealing with infinities, you need to make sure that things can actually exist, the global extremas. So we pick a test point, plug them into the derivative because we're working with a derivative number line. So just like with the local stuff, whenever you're working with a number line, it deals with the derivative. Which is also, remember why I said I like to label these R prime. so that I remember that's where the things go into. So if you need a number line, it's with the derivative. If you're not working with a number line, it goes into the original function. Why did I write f prime? So what is r prime of 1? It's going to be -6 plus 780. That's going to be positive. I don't know what that is. 774, I think. What's r prime of 70? Okay, I'll actually figure this one out. Oh, I plugged in the wrong. No one called me out on that. -12 plus 780. Because I'm plugging it into the derivative, not the original one. Bad. Did a terrible thing. Don't be like me. I'm sorry, I really don't know what's wrong with me today. So -12 times 65 plus 780 will plus. I'm losing my mind. Is -60. You get a negative there. Increasing, decreasing. Means it's going down forever in both directions. Sorry about that. Says it's going down forever in both directions. There's going to be no global min, which we don't really care about anyway, because they weren't asking us for a min, they were asking us for a max. But since it takes that shape, we know that the maximum does exist, so it's going to exist at that global local maximum, which ends up being the global maximum. So what were we actually asked for? What price should the company charge? So we technically don't even need to plug it back into revenue. So the price max revenue. I'm just going to say when P equals 65 because I'm running out of space. So if they had asked for the actual maximum revenue, we would have to take that 65, plug it back into the original revenue function and figure out what the revenue was. But they don't ask for the actual maximum revenue, so you can find it if you want to. But whatever floats your boat. So sorry about all the stupid stuff I did at the end of that. Any questions on that? One thing that I want to say before I forget to say, because it kind of comes up on your homework a little bit. So there's a couple questions on your homework where you find all the things and then you're asked to classify them as global or local. So the global ones just follow what we've done for global. Essentially, let me go back here really quick. So I forgot to mention this because I honestly didn't think it came up in your homework and I thought it would be more confusing than it needed to be, so I decided not to talk about it, but hey, it turns up in your homework, so now I gotta talk about it. The endpoints can also be considered local maxes or mins in these cases. So in something that looked like that, even though the right endpoint doesn't end up being a global max or a min, based off of the shape of this graph, so you kind of need to look at the shape of it. You can also kind of compare y values, but it's harder to do. But if you look at the graph here, in that relatively small area, that's the highest point in that relatively small area. So that point would also be a local maximum. So the endpoints can also turn out to be local extrema when you're talking about cases like these. That does come up on your homework. Forgot to mention it. So if you want to classify them, classify the global like we were already doing. Everything else that's not a global is going to be a local something. If it's something in the middle, if it's a critical point, then you just find whether it's a local max or min using your little sign chart doodad. And then you usually need a little bit of a picture to see the rest of them. Or you can guess. But I mean, whatever floats your boat. So anyway, I forgot to mention that. I'm sorry. If you have questions on your homework, let me know. But now you can do all of it. So hooray. So now it's time to take our quiz. So remember, your quiz is just like the warm-up. Just here's a function. Here's an interval. Find it. Let me stop recording.